Yeah. Yeah, it's done.
Whatever they broke up for you, they didn't work out for you back.
Yeah,
exactly.
and they're like, I had it better, you know? Much better. Yeah.
I'm not gonna get involved.
I've seen it like 5 times, but you know what show I've seen like 100 times? Like seriously, The Office. Have you seen it?
All right, guys. Yes.
You're more part.
I don't know.
Person like it's the kid, and I like.
So,
but
before age 65, which kids is that? 21 through 50. So what total percentage? Add those up. Yeah. Cool. Okay. Anything left over on this sheet here? This is basically the kinds of questions that I ask on this kind of problem. These variations on these. Okay. All right. So that's 4142. I remember correctly. 43 is something called binomial distributions. Now we're not going to suddenly start doing polynomial stuff, right? Bless you. You remember from algebra binomial what that meant? Two nomials. Two terms. Polynomial means many terms. Binomial in algebra is two terms. Binomial in statistics, what does nomial sound like? Nominal kind of data, right? Names. So binomial distribution is a distribution where there can only be two outcomes. You with me? Okay, I like it. So is rolling a die an example of this kind of distribution?
Yes.
Could be. If I said I want to get a 5 or not a 5. So that feels a little weird. But you're playing Yahtzee. What's probably get all 5s? Well, then you have to think, I want a 5, and what's the opposite of that? Not a 5. You with me? A little bit? If you don't know what Yahtzee is, I'm sorry. It's okay. You can look that up. Now, so we do this example. I still like to do this example, even though it's not quite. How many left-handed people in here? If you, we're gonna. So 1, 2, 3. 1, 2, 3. All right, and then there's 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. So 3. So 3 divided by 26 is roughly 11%, isn't it? That's neat. Somebody can help me out? No, you're all like, that's your thing, man. Math boy, there it is. It's 11 point something percent. 11.5. Roughly. Okay. Yeah, 26. Yeah. And that's kind of, I don't know if you guys have heard, I mean, that's like the accepted percentage of left-handed people in the population is 11%, roughly. So it didn't have to be that way, but it's kind of neat that it did come out that way. I would expect 11% of any group to be left-handed. Will that expectation bear out every time? No. So, but do you see how that kind of thing, that kind of ability would be, how many left-handed seats should we put in the classroom? Well, you can do 11% of the seats, and then maybe add 1 or 2 just to be safe. Does that kind of analysis is really useful. Okay. So let's say the probability of a left-handed person, we'll just make it 11%. Is that cool? We'll make it 11. We almost hit exactly the number. So the probability, I think the book uses something different, but I use this to be not left-handed. Why would I just say right-handed? If you're not left-handed, are you necessarily right-handed? You might have lost your right hand, right? And you're not left-handed, and that sucks, right? Or maybe you don't have any hands, or maybe you're ambidextrous, right? You my right arm to be ambidextrous, but just am not. So what's probably, this means not left-handed, so it just covers every other possibility. So it's probably somebody's not left-handed. What's probably somebody's not left-handed?
29.
It's got to be 0.89. Or is there anything else? Left-handed, not left-handed. Is there any other possibility? No. That covers everything, right? Okay, I like it. All right. So if I randomly choose, randomly choose 5 Americans. This is all about America. I don't know what it is now. Americans. What's the probability that exactly one of them will be left-handed? Does everybody understand the premise, the setup here? I've got 5 people. I want the probability that exactly one of them is left-handed. Can you please understand why 1 out of 5 ain't got shit to do with this problem? Very often I'll have somebody tell me the answer is 1/5. That makes no sense. I don't have 5 people and one of them is what I'm looking for. It isn't. You guys with me? So don't do that. That's way too basic because you didn't even take this into account at all. If this was higher, then this probability should be lower. You guys understand that? This is a low probability, so out of 5 people, I would expect maybe around 1, right? Maybe? Yes. If this was a higher, 90%, I would expect 4 of them. That should be the higher probability. So it's got to be somehow based on this. Okay. You guys with me a little bit.
Is it 2?
Sing it.
Is it 2?
Is it true?
2.
2. What about 2?
Probability of 1 of left hand is it 2?
2?
The probability of 1 left-handed is it 2? Yeah.
So there's a lot of things kind of weird about that. 2 is greater than 1, so that's a problem. How did you get 2? Where'd that come from?
Either you don't have.
Oh, now you're like my little brother. Did I tell you guys about my little brother? Yeah, I don't want him to be a surgeon because he's like, you're going to survive or you ain't. See you on the other side. All right. So he's the guy that would say, the probably is going to rain in San Diego. It's probably going to snow today. It's 50%. Because either it is or it ain't. And that's bullshit. There's never a 50% chance of snow in San Diego. I'm sorry. Right? Okay. Or maybe. Is that cool? Anybody else questions right now?
The chance of you the probability of you choosing exactly one lefty, would it be 11%?
No. Because again, if I did it out of 5,000 Americans, was probably get 1, it would change. It wouldn't be the same. So it depends on this, it depends on this, it depends on this. We haven't put it together yet. I'm not asking you that yet. I love you guys. It would be so mean for me to ask you that because you have a freaking clue right now. Well, it's not quite true. You guys do have a clue. Can you give me one situation where I get one left-handed person? Yes.
11% times 89% times like 4.
Okay, so break that down. Don't give me numbers. So you're saying the first person is left-handed?
Yeah.
And then these guys are not.
Right.
Let me do something for myself. Let me re-represent this. What am I looking for? I'm looking for left-handed people, right? I'm looking for one left-handed person. So we're going to call this, it's binomial, so there's always 2 situations, or else it ain't binomial and none of what we're talking about is applicable. This is a success, because I'm looking for a left-handed person. Success doesn't have to be nice. I could be looking for dead bodies, so finding a dead body is a success. I could be looking for rabid squirrels, so finding a rabid squirrel would be a success then. You guys with me? So success doesn't mean, oh good, it happened. Success is, that's what I was looking for, right? So I'm looking for left-handed people. I'm going to call this P. P means probability of success. And I'm going to call this Q. Q means probability of failure. So what must P plus Q always be? Good, 1 or 100%. That's how we got this when I just told you this by itself. Okay, I like it. Good, good, good. So now it's just going to make it easier for me to write this. So instead of this, either the first guy is a success, or girl, I don't know, and then the other ones aren't. You with me? That's how my Q's look, by the way. Sorry. Some of these are. What's that E? Oh, that's a Q. Leave me alone. Or what else? Right now, watch. Wait. Why am I kind of like multiplying it? The first guy is left-handed, and the second guy isn't, and right? And means multiply. Or what's that mean? Okay. Or what's another way to do exactly what one left-handed person? What's this way? The first one was left-handed. What's another way? Second one. Oh my God. So and Q, P, Q, Q, Q. Or Q, Q, P, Q, Q. Or Q, 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 P, Q. Or Q, 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 P. Now, what would algebra say about this? I'm writing a lot of shit, but I want you to realize what goes into this kind of problem. Huh? Yeah. So I got 5, but the same thing. Each one of these, if you multiply these out, what do they all look like? What is P times Q times Q times Q times Q? What's a better way to write that? P times Q to the 4th. Okay, so they all look like this, right? And and how many of them? 5. So let me break this down. You guys semi with me a little bit? A little tiny bit? Because how do I get a probability question answered? I have to add up all the situations that match what it's looking for, right? That's why if I say probably man or said no, you add up all the men and all the ones that said no, right? Subtract however many you broke that. You guys kind of with me? So I have to take every situation that matches with what this wants and add them together. Of course they're going to all look like this. What does this mean? I got 1 P, 1 left-handed person, which means I have to have 4 not left-handed people. 1 success, 4 failures, and there's 5 ways to do it. No? Yes? Maybe? Yes? This formula is almost kind of scary when we get it put together because it kind of just reads off like a sentence, because that's what formulas really are. They're just sentences in a different language. Mathish, right? Okay. So we could actually figure out this number. Does everybody see that's a 4, not an 11? Right? Because there's 4 Q's. So that would be 5. So in this case, it would be 5 times 0.11 times 0.89, right? To the 4th. Somebody help me out. .3 something? 345. That's neat. All right, so like a 34.5% chance that you'll have a group of 5 people with just 1 left-handed person. I like it. So, what was this number from again? Why is that a 5? Because there's 5 ways to match what you're looking for. Now, here's something I've never thought to do. I'm going to do it right now because I just thought of this. Kicks ass. There were, I can't remember now, shit. I had it up here. How many people were in here? Huh? 26. Okay. So let's do a different problem based on this. So again, P is 0.11, Q is 0.89. Same problem, except now, if I have 26 people. Oh, let's just have 26. 2, 4, 6, 8, 10, 14, 16, 26, 27, 28. So 28 people. And then done that. Real quick. How many left-handers again? 3. Nobody else that came in late was left-handed? Okay. All right. Don't worry. We're not going to kill you or some ritual sacrifice. No. So if I have 28 randomly selected people, you guys aren't really randomly selected, but I don't care. What's the probability that I have exactly 3 left-handed people? Now think about this for a second. Do you even do this for me? Write down one possibility. There's 28 spots. Are you with me? So maybe it's. I'm just going to start and we'll see. Maybe it's the first 3 are successes and the other ones aren't. Or maybe it's the first one and these 2 and the other ones aren't. Or maybe, do you start to see how long this stupid list is going to be? Okay. So you're going to have to, no, I'm joking. You're not going to have to write the list. Holy shit. This first number, this was simple because there's only 5 ways to do this. This one, we're going to calculate how many ways there is to do. We're going to make the calculator do it for us. We're going to make the calculator calculate. That first number, we're going to make the calculator get it for us. It's a calculator. It's count shit as a basic function. So it's going to cost enough money. Let's put it to work. But, so I'm going to have a number here that I can't get yet. It's not a face. It's a number I can't get yet, right? Like that 5. Is everybody with me? Mm-hmm. Just give me how long the list is. I don't want to make it. Let's just make the calculator count how long the list would be. But what's going to go here? P to the what? Q to the what? P to the what? Third power. Because how many successes do I want? 3. So how many failures do I want then? 25. Does that make sense? What do the powers always have to equal? The total, because you're one or the other. So you're just like, I lost both hands. Well, then you're not left-handed. You're a Q. You with me? It covers everybody. So this will be 25. Those add up to be 28. Everything looks good. So I can get this piece of it. Let's talk about how to get this piece. Okay. And here's how this kind of works. This is a piece of counting theory that we really just don't have enough time to get into, but I want to tell you about this one piece. Let's first double check that the calculator can tell us this is 5 before we trust it to try to do this one. Right? So another way to say this is I have 5 people and I want to choose one of them to be left-handed. So if I put that in the calculator, I have this many people and I want to choose this many. It's going to tell me how many ways to do that. And it should tell me there's 5 ways. Everybody with me? A little bit? Tiny bit? And the way that looks is exactly how it sounds. 5, choose 1. So this choose, it's a function. And what it does, it actually does, let me say this, just to let you know a little bit more of the story. The function, I'm not going to make you use the formula for this, but I want to tell you one piece of this. Have you guys ever seen this before? And it's a math thing. It's not like 5. How many crocodiles? 5! Okay. Yeah, I'm sorry. Who knows what that means?
It's a factorial.
Factorial, kick ass. 5 factorial. And what does that do? Yeah, so this would be 5 times 4 times 3 times 2 times 1. So this is a very basic function that goes into counting formulas. So for example, if I wanted to count how many 5-digit numbers I can make not repeating something, or how many, if I had 5 people, how many ways can I line them up against the wall? Well, the first person I got 5 choices. The second person I only now have 4 choices, and for each of those I have 3 choices. So if I multiply it out, that's how many ways I can line 5 people up against the wall. So that factorial is a very basic component to build counting stuff off of. So if you look at the formula for this, you're going to see a bunch of exclamation marks. I think the book's got the formula in there. But this is one place where I'm totally cool with just making the calculator do this for us. It's just counting shit, so I might as well just do it. So how's this look in the calculator? I don't know. Oh yeah. If you have the newer one, it actually looks just like that, what I wrote up there. And if you don't, it don't. So everybody do this. Put 5. And then the other button that I hope somebody out there, if this is the first time you ever seen one of these, somebody was going to push this button right there. Did anybody push that math button? You're like, that has got to be intriguing. It's not going to suck you into this Tron-like world where you got to solve math problems to survive. That sounds really cool for me. But no, if you touch it, if you push it, you get a list of all kinds of shit. Look at all that shit you can do. So one thing you wish you knew about before. Let me do one thing on the side here. Watch this. 0.5487 math to fraction. Or look, that was exciting. 0.548. You can only handle up to so much. There. Makes it to a fraction reduced. My Math 88 students wish they could have done this. Anyway, so math has got a whole lot of shit down here. Go over to probability right now. What we're going to use is this one. Now, just remember they got to go back and put that 5 back in, right? So let me put that 5 back in. 5, math, probability, choose. That's your choose. You don't want National Public Radio. You want NCR. 5, choose 1. So 5, choose 1. If you have an older calculator, it just has an NCR in between your 5 and your 1. Are you with me? Or a lot of you guys, it should look like this. So that's got to be 5. How many ways is there to choose one thing from 5 things? 5 ways. Now let's do this one. What would this one look like? Oh shit. I seriously need to hire somebody. Some guys like, dude, pay me? Yes. I wouldn't blame. What should this look? I'm sorry? 28. Choose 3. So choose 3 people from 28, 3 successes, 25 failures. That is how that reads. It describes the situation in the freaking formula that kicks so much ass. So watch this. What is this by itself? 28, choose, what did I say? 3. So if we try to make that list, this list, it's 3,276 long. You with me? Yeah, I don't want to do that. Thank God we got this calculator that'll count it for us. It doesn't actually make the list and count it. It uses factorials in a neat way, but it ends up representing how long the list would be. So that's what number was going to go here. So how would I put this whole thing in the calculator? I would do this all at once. So everybody with me? Ready? 28. Choose 3. Now here's the one little thing you gotta get over to get back up out of there. You guys with me? If you got the newer calculators. Times, what's P again? 0.11? To the 3rd, hit over. Times 0.89 to the 25th. So from 28 people, choose 3 of them to be a success. So we got 3 successes, the rest are failures. That formula's so flippin' cool. So what is that chance? So there's a 20, almost a quarter chance. So 23.7% chance that was going to happen. So it's pretty likely. So the fact that we got 3, it's pretty likely. It makes sense. It wouldn't be unusual that happened. What if there would have been nobody that was left-handed? What would that formula look like? So this came out to be 0.2367. Probably no lefties. Be 28 choose. 28 choose 0. So I'd have 0 of these. And I'd have how many of these? All 28. How many ways is there to choose nobody? No. Come on, you could be better. How many ways is there for me to right now choose nobody? 1. All right, Arya, come with me, Arya. No Game of Thrones people? Fine. There's only one way for me to choose nothing from a set. I choose nothing. Right? Not how many ways can I say it, just how many ways can I do it. There's just one way. I don't pick anybody. So if you type this to the calculator, it's 1. What's anything to the 0 power? Anything to the 0 power is 1. Sweet. 1 times 1, so this is the only thing I have to pay any attention to. 0.89 to the 28th So if that happened, if there would have been nobody that was left-handed in here, that would have freaked me out a little bit. It would have been unusual. That's less than 5% chance to happen. Okay. Maybe? Yes? No? You're right. Okay. So let's do another situation from the top. That's just without me explaining all the pieces. Yes?
So, what the question was asking that, what is out of 28 people, what's the probability that none of them?
Yeah, this one we just did. Yeah.
Okay.
So if there would have been nobody in here that was left-handed, that would have freaked me out a little bit. Because it's only a 4% chance, less than a 4% chance that happens.
That not one single person.
That not one single person out of 28 people.
Okay.
Same time, it wouldn't totally, because you are a biased selection, right? You are in this class at this time in the summer for a reason. So maybe there's more or less chance somebody's left-handed in that situation. You guys with me? But still it kind of applies. Okay. So let's do a clean problem, devoid of explanation of concepts, and just see how this works. Sorry. I don't know if I told you that. I think I did. We talked about rate my professors, right?
Yeah.
And my favorite one was the guy that said, he's literally there just to explain concepts. I'm like, yes. So I'm doing a good job. Thank you. I don't know, sorry. So let's say there's a 72% of Finnish people drink more than 4 cups of coffee each day. I am part Finnish, so this is really close to true. Finns and coffee are like, coffee runs through our blood. You guys with me so far? Now, obviously, I just made that shit up, but it's roughly based on truth. Okay. So let's say this. Let's say we know this. And I randomly select 12 Finns. Cool? What's the probability that exactly 8 of them do this? So let's summarize a few things for ourselves. What is N? I got 12 total people I'm looking at, right? What's P? 0.72. Probability of success. Finns that drink coffee. I'm looking for Finns that drink coffee. So what's Q? Got to be 0.28. Because these two have to always make 1. Aw. Okay. Let me throw this at you. What is X? It's kind of like process of elimination. What's the only number left that I haven't used yet?
4.
No. 8. 8 successes. So X is the number of successes. X is the variable. Because I could look for 8 Finns at success. I could look at 7, 6, 5, anywhere from 0 to 12. So X is the value that I'm currently interested in. So how would I set up this probability? I've got 12 people. Choose 8 of them. 0.72, how many of these you want? 8. I like how it's a little repetitive, right? Choose 8 people to do this thing. So there's 8 of these. And how many of these? Now you bring in the 4. The rest of them have to be failures. They failed as Finns. Not drinking enough coffee. They'll be thrown out of the country. Yes?
How did you get
P is the probability of success. U is the probability of failure, so the 2 always have to add to be 1. Yeah, so you just do 1 minus this. By the way, real quick. I have no idea if this is annoying, and I actually don't care. A little side note, because this happens a lot to us. How do I do 1 minus 0.8476 in my head? I'll show you. What makes this 9?
1.
What makes this 9? What makes this 9? What makes this 9? 2. What makes the last one 10?
4.
That's what it is. Why does that work? What's 10 minus 8? What's 9 minus 7? 2. See, if I move things around, the difference is the same. If I move them around the same amount. Stay with me now. What sucks, now if I made you do this by hand, oh my freaking God, wouldn't this suck? Look at all the borrowing you gotta do. Right? All the borrowing you have to do. But let me make this go down by 1. Minus, and make this go down by 1. Do you see that? That's the same answer as this. They're the same distance apart. You can do this anytime you got too much borrowing to do. And I know some of you guys are like, I got this thing called calculator jam. I don't give a shit. It's nice to be able to do this. So you guys see why that shortcut works. It make everything 9, except in that last one you make 10, because it wasn't really a 5, it was this anyway. So that's kind of neat. That always works. So that's 0.72, so this is going to be, make it 9, make the last one 10. 2.8. Because we get too many people tell me it's 0.38, and then the whole problem's to shit, right? You guys kind of with me? No? You don't like that? You still can use your calculator. That's fine. I'll give up. Okay. And now, let's go ahead and plug that in the calculator. Let's see if you guys can get the same thing I get. Don't say anything yet. Catch up. What I say. All right, so I get that. So what you guys got? Cool, I like it. Sweet. So about almost a 22% chance that any group of 12 fins will have exactly 8 that drink that much coffee. I like it. And by the way, this type of analysis we're doing, has anybody ever gone to the airport